Good morning to all of you. In last lectures, we have discussed regarding the advantages, disadvantages of control release drug delivery system, as well as we have discussed regarding the maintenance and loading dose. In today's lectures, we'll discuss about the classifications and the various approaches for the controlled drug delivery system. So, as we know, there are two general sets of methods that have been developed for the implementations of practical sustained release dosage form designs. So the methods which are based on modifications of the drug release rate, which is characterized by the modifications of the physical and the chemical properties of the drug, and by modifications of the drug of the dosage that will affect the bioavailability. So the physiochemical properties of drug that can be altered by complex formations or by drug absorbed preparations or by the product synthesis. So these techniques are possible only the drug candidate or the APIs which containing the appropriate functional group, means either acidic or a basic groups. So the principal advantage of using this uh, approach to sustained release is that it is independent of the dosage form designs. So drugs, so modified, may be formulated as a liquid suspensions or capsules or a tablets. So the complex formations, or we can use product absorbed preparations. So that's why they are defined, or they uh, provide the proper release for our drugs. So control release drug delivery system, they are basically classified on on the basis of technical sophistications and on the basis of routes of administration. Routes of administration, there are various routes are there that can be used for the to carry out the control release drug delivery system. Basically, oral routes are there. Gastroretentive drug delivery systems are there. Transdermal drug delivery systems are there. Ocular drug delivery systems are there. So these are the various systems that we can adopt it for the delivering the medicament with a continuous or sustained release manner. Then, under the technical sophistications, CRDDS again divided into three classes. First is our rate program drug delivery system, stimuli activated drug delivery systems, and site targeted drug delivery system. So the apart from the site targeted drug delivery system, this particular rate program drug delivery system which contain drug, the rate controlling element, let's say the polymers will be there, and the energy sources that activates the drug delivery system. So basically, rate program drug delivery system means what? So in this particular drug delivery systems, these are the systems are those from which the drug has been released with the proper program at a specific rate profile. So they are further divided into dissolution control, diffusion control, erosion control, or in a combinations of these three. So basically dissolution controls means what? So these are the systems where the rate limiting phenomena responsible for releasing the drug or imparting the controlled release, which is characteristics by two ways, either slow dissolution rate of the drug or slow dissolutions of the reservoir membrane or a matrix systems. They are dissolved in that specific manner. Second one, diffusion control, where the rate controlling step is not a dissolution rate or the rate dissolution rate of the drug, but depending upon the diffusions of dissolved drug molecules through the rate controlling elements. We're going to see the classification and we are going to see the details about the dissolutions control and a diffusion control. And in an erosion control system, so erosions, as we know, which is called as the physical disintegrations of the polymers or any matrix that are coating as a result of degradations and is characterized by the material which is lost from the polymers, mostly generally for the physical state. So there are two types of erosions will occur. Surface erosions are there and bulk erosions are there. So surface erosions which will occurs from the surface layer of the device and the bulk erosions which will occurs throughout the polymer bulk and the process which is also called as a homogeneous erosion source. Means the drug is entrapped in a specific matrix and they will get eroded throughout means so in a surface erosions only the surface layer of the drug that will get uh, so there is erosion will occur. So basically it will result in decrease in the size of the device. And here bulk erosion occurs when the water is readily able to penetrate the matrix. So what will happen? Bursting effect will be there and they will release the medicament in a sustained ways. Then we can use either uh, dissolution, diffusion and the erosions in combination space. So these systems, the combination systems are those systems where the rate of drug release is controlled by the drug or polymer dissolutions, drug diffusions, and polymer erosions. So either it is the combinations of two or either it is the combinations of the three systems which is we have discussed. We'll discuss in detail about the dissolution control and diffusion controls throughout the topic, but the just remaining I will just end this and what exactly there that we are going to discuss now in a stimuli activated drug delivery system, that is second type of technical sophistications control release drug delivery system, which is again further classified under the open loop system or closed loop system. Open, or we can call as the pulsatile systems, or closed systems that is called the self-regulated systems. So basically in this particular stimuli activated drug delivery system, the drug release is activated by some physical stimuli or either biological or either chemical stimuli by energy supplied. That energy is supplied by the external. So the release of drug, which is in the response to stimuli, which is the result of dramatic change in swelling behavior, or sometimes the network structures, whatever the reservoir or whatever the matrix are forms. So they change their structure, network structure, or the permeability or the stability of the drug delivery systems. So basically, these types of systems are capable of releasing the drugs in response to stimuli, either chemical stimuli, either physical stimuli, or either biological stimuli. So they are also called as the smart or intelligent drug delivery systems, or we can also call them as a environment sensitive drug delivery systems, as they are triggered to release the drug in response to the external events. There are some stimuli activated drug delivery systems that is based on hydrogels. So as we all know, hydrogel, which is a 3D polymeric structures, hydrophilic polymeric network structures, which is capable of swelling in water or biological fluids and retaining the large amount of fluids in the solent state. Now, as already I have discussed, the stimuli related or the stimuli activated drug delivery system that can be classified on the basis of applied stimuli into two categories: open loop system, we also call as a pulsatile system, or closed loop or self-regulated systems. So, open loop system, these are the systems where the informations about the control variable is not automatically detected and which is triggered by the external stimuli. Generally, phonopheresis we are using, ultrasounds are there, temperatures we can use here, or electric currents are there. So these are the open loop system that is controlled by the external sources or the external stimuli. So like some photochemical waves are there, lasers activated or drug delivery systems are there, or electrically activated drug delivery systems, and we already discussed in last year. Ionophores we have discussed, or the electroporations we have discussed, or magnetically active drug delivery systems are there. So that all comes under the open loop or the pulsatile drug delivery systems. And in the closed loop, or we call them as a self-regulated drug delivery system, or we call as a feedback regulated drug delivery systems. So in this, those were the informations about the control variable which is detected as a result of the system's output, which is adjusted accordingly. So this particular closed loop, they produce the stimulus without any external interventions within the body to control the change in drug delivery systems and to exhibit the desired drug release. So basically, they are enzymatically or that are based on the enzymes, or they are utilizing some different approaches like the chemicals or the biologicals, or for some control mechanisms such as pH sensitive polymers we can use, or the enzyme substrate interactions are there. So basically, stimuli activated drug delivery systems. So with the help of either internal sources or by the external sources, they are activated and they are releasing their medicament. In an open loop system, we are using some external stimuli like some magnetic radiation, some electromagnetic currents will be there. So through which we are activating our devices and then it will release the medicaments. But in a closed loop or a self-regulated system, we are using the uh, means, without external stimuli. What are the different uh, stimuli which is present in our body, like a biological stimuli or like a chemical stimuli are there? So that we are using to deliver our drug. So basically, stimuli activated drug delivery systems that can be classified on the basis of their activation process or the types of energy that can be used. Means, suppose we are talking about the activations by the physical processes. So there are osmotic pressure pumps are there, vapor pressure activated drug delivery systems are there, photo activated drug delivery systems are there, electrically activated drug delivery systems are there that we call as the iontophoresis or the electrophoresis also. Then activations by the chemical reactions are there. So chemical process are there, means pH dependent or the pH activated drug delivery system. The pH dependent solubility systems are there. pH dependent erosions or the degradation systems are also there, and pH dependent swelling systems are there. So depending upon the erosion mechanism or depending upon the dissolution or the diffusion mechanisms, as we have already discussed here. So this stimuli activated external or the chemical process activation by the chemical process, these control drug delivery systems are delivered. Some ion activated drug delivery systems are there. And by the biological system, as I already discussed, some enzyme activated drug delivery systems are there. Suppose urea responsive drug delivery systems are there, glucose responsive drug delivery systems are there, or antigen activated drug delivery systems are there, or inflammation activated drug delivery systems are there. So these are the different classes that we are talking about the stimuli activated drug delivery system. Here we are using open loop साठी आपण external stimuli utilize करतोय. Okay, so basically controlled drug delivery systems that are classified on the basis of two ways or the two method, not a method we can call this particular ways by which the controlled drug delivery systems are classified. First is our depending upon the technical sophistications and depending upon our routes of administrations. So technical sophistications, they are again categorized into three major classes. That is the rate program drug delivery systems, where drug delivery systems in which the drug release has been properly programmed at a specific rate profiles. Then stimuli activated drug delivery systems. That means they are activated either by the internal stimuli or either by the external stimuli. So rate program drug delivery systems again further divided into dissolution control, diffusion control, erosion control, or in a combination way. There is a stimuli activated drug delivery system which is delivered which is characterized under the open loop system or the closed loop system or pulsatile or the self-regulated system. And last one, that is the site targeted drug delivery systems. So basically, uh, these are basically whenever we are using the most of the conventional dosage forms, so they deliver their drug into the body that eventually reaches the sites of actions. Thereby, the multiple steps means transformations will be there, diffusion will be there, dissolution will be there, or different barriers are there. So there is a one advanced systems are there, the site targeted drug delivery systems. So basically, in a conventional dosage form, drug is also distributed to the non-targeted tissues also, and that's why they may causes some toxicity or some adverse reactions will occur. So selective and targeted drug therapy that has to be used, so that can be that can be results into the optimum and more effective therapy, but also it will reducing the dose as well as the cost of the formulations. So basically, site targeted drug delivery systems that are classified into three broad classes: first order targeting, second order targeting, and third order targeting. Means first order in a first order targeting, which will refer to the drug delivery systems that delivers the drug to the capillary bed or to the directly active cells. Second order targeting systems that delivers the drug to the special cells types like a tumor cells and not to the normal cells. And third order targeting refers to that deliveries, that is drugs are interactively processes. So the site specific or the site targeted drug delivery systems also they are characterized on the basis of their transport system by the passive targeting or by the active targeting. So they are passively disposition of the drug carrier is based on the physiochemical characteristics of the systems, and in active targeting, we will alter the natural dispositions of the drug carriers and we will direct it to the specific cells or specific organs or to the specific tissues. So, so this is the classifications of control release drug delivery systems. Now, for our syllabus, we are mostly concentrating on these two systems, dissolutions control and a diffusion control drug delivery system. So let's start with the dissolutions control drug delivery systems. So in a dissolution control drug delivery systems, the drug release device which is controlled by the dissolutions of either polymeric membranes which is surrounding the drug core or the polymeric matrix which is containing the drugs. So here in a dissolutions control system, we have seen different pharmaceutics as well as the pharmacokinetic properties that will affect on our controlled drug delivery system. So here that all the factors or all the conditions has to be studied. Just 1 minute. Okay. So here the drug dissolutions which will be carried out either by the polymeric membrane surrounding the drug core or the polymeric matrix which is contained in the drugs. So here the dissolutions of the polymeric material which is the keys to these mechanisms, all the polymers that we are using are water soluble or degradables in a water. So whenever we are using the dissolution control system or the diffusion control systems, so they can be designed either in a reservoir system form, either in a matrix system form, or either in a hybrid system. Now reservoir system, that is the membrane control systems. Matrix systems where we are using the soluble, erodible, or the swellable or the degradable systems, or the hybrid systems where membrane or it can be means these systems where the drug which is the matrix is releasing retarding materials which is further coated by the releasing coating materials are there. So these are the three basic mechanisms or the three designs that you are using, either by the matrix system, either by the reservoir system, or either by the hybrid systems. So the rate limiting phenomena or the dissolution control systems, it is responsible for imparting the control release of characteristics to the drug delivery system by either two ways. So either a slow dissolution rate of the drugs. So in a slow dissolution rate of the drugs, so drugs which is present in such a systems that can be either drugs which is having inherently slow dissolution rate like a crizofilmin or the digoxins. So they are naturally acting prolonged release product. Means they already have the slow dissolution state. And second one, the drugs that transport into the slow dissolving forms when it comes in contact with the GI fluids or the internal environmental conditions, like a ferrous sulfate. So these are the two characteristics or the two systems are there by which the slow dissolution rate of drug is carried out. Then second one, that is a slow dissolution rate of the reservoir membrane or matrix. As already I have discussed, this all the dissolutions or the diffusion control or the erosion control drug delivery systems. So to develop those systems, we are using either a matrix systems, either we are using the reservoir systems, or either we are using the hybrid systems. So these three systems that we are adopted. So slow dissolution rate of the reservoir membrane or a matrix where the drug presents, which is any system, in any system like a membrane or in a matrix form. So such systems they have high aqueous solubility and high dissolution state. So the challenges in designing such systems that we are controlling the drug dissolutions by either embedment in slowly dissolving or degrading or erodible matrix or encapsulations or a coating with the slow dissolving or the degrading or eroding substances like a polymers. So basically fluid penetration, so the rate of dissolutions fluid penetrations and the vitality of the reservoir systems are controlled. So let's see what are the matrix and what are the reservoir systems are there. So matrix dissolution system is that this approach drug is dispersed in a slow dissolving matrix which consisting of polymers. So these are the systems where the drug is uniformly dissolved or dispersed in a release retarding materials. So here we can see this is our soluble drugs which is dispersed. This is our drug candidate. It is dispersed in a slowly dissolving or erodible matrix or the materials. So they can be formulated as a conventional matrix or the bilayer or the trilayer matrix systems. So depending upon the physical properties of the matrix, they are either classified into hydrophilic matrix or hydrophobic matrix. So here the rate of penetrations of dissolution fluids into the matrix determines the drug dissolutions and subsequent release. So as I said, depending upon the physical properties of the matrix, we are using the hydrophilic matrix or hydrophobic matrix. So in a hydrophilic matrix, where the release retarding materials are water swellable or swellable cum erodible hydrochlorides, like a high molecular weight hydroxypropyl methyl cellulose, hydroxypropyl cellulose, or hydroxyethyl cellulose. The xanthan gum will be there, sodium alginate will be there, and there are various cross-linked polymers of acrylic acids are there. So hydrophilic matrices are used which are porous systems. So depending upon the swelling behavior of hydrophilic polymers, two types of matrices are possible: free swelling matrix and restricted swelling matrix. The free swelling matrix is the one in which the polymer swelling is unhindered, means त्याला कुठेही कंट्रोल नसतो. फ्री स्वेलिंग तो स्वेल होतो आणि बस्ट होतो. And restricted swelling matrix, so where in which the surface of device is partially coated with some impermeable polymer film that restrict the hydrations of swellable matrix materials. So matrix, hydrophilic matrix, which is again divided into free swelling matrix and restricted swelling matrix, and hydrophobic matrix, that is they basically on where the release retarding material is depending upon that slowly soluble or slowly erodible, like wax are there, like such as glycerol monoxide are there, acetyl alcohols are there, carnauba wax is there, beeswax is there, that can be used here. Hydrophobic, that name itself gives, they are retarding the water. And second one, insoluble or non-digestible are there, like ethyl cellulose. So depending upon the manner of incorporation of the drug, there are porous matrix are there, or there are non-porous matrix are there, or there are some again non-porous are divided into dissolved drug non-porous systems or the dispersed drug non-porous systems are there. So this is one approach that we are using. It is called as the matrix dissolution control. And second, so matrix and reservoir types of systems. It is also known as the monolithic dissolution control systems. In these dissolutions, which is controlled by first thing, we can alter the porosity of the tablets. We can decreasing its wettability. We can reduce the rate of dissolving capacity. Also, it follows the first order drug release mechanisms, and the drug release can be determined by the dissolution rate of polymers. This is the matrix system. Then reservoir partition systems are there. So reservoir system, or we also call them as a membrane controlled drug delivery systems or partition controlled drug delivery system. So in such a system, The drug core is enclosed in partial soluble membranes. So they are encapsulated. And there are some pores, so that's created due to the dissolutions of the part of the membrane which permits the entry of aqueous medium into the core, and hence drug dissolution will occur. What are here we can see is that this drug is encapsulated with the help of the specific polymers, and here when it comes in contact with water or the gastric juice, here we can see they open up some pores and they allow the aqueous medium to enter into the core, and because of entering the aqueous medium, the drug dissolutions will be occurs and drug will be released here. So that is called as a reservoir partition control drug delivery systems. So to allow the diffusion of dissolved drug out of the system. Here matrix system, there are hydrophilic matrix or the hydrophobic matrix. They will allow the release of your medicaments by dissolving or dispersing the retarded